I am Sakshi, a GenAI expert at Pi by 3. Today I will be presenting AI over BI and intelligent dashboard reasoning system. Let me start with the problem statement. Retail dashboard already show important KPIs like sales, profit, orders, growth, etc. But these dashboards are visualization centric, not insight centric, which leads to several key challenges such as manual exploration, knowledge requirement of chart, lack of cross KPI reasoning, and analyst dependency. All these challenges impact business by causing slower decision, missed early warnings, underutilization of BI, and overloading analysts with repetitive queries. Our solution proposed an intelligent dashboard reasoning system which adds an AI layer on top of BI, which understand the KPIs, their relationship, allow users to chat with dashboard and generate insight. All this can be achieved by using KPI universe, which consists of primary KPIs, derived KPIs, business meaning, guardrails, and decision areas. One key feature of our solution is AI reasoning with evidence, wherein all answers are backed by the actual dashboard data. And as a result, the final outcome is quicker decision, less dependency on analysts, and dashboard that are much easier to use across team.
Hello everyone, this is Niveda Vellepandi, a Gen AI expert at Pi by 3, and this video showcases our demonstration of project AI over BI. Quickly starting with the demo. Now this is a basic retail performance dashboard created in a BI tool called Metabase. This is a detailed dashboard which shows the performance of retail including sales, profit, monthly sales performance, contribution percentage, etc. It also has data related to the operational and trends analysis. Now suppose a C-suite person has a query on this dashboard data. They have to manually go on exploring the entire dashboard, the KPIs present in it, apply filters, and then derive insights based on their analysis. This is a time-consuming manual and not an efficient approach for them. Hence, we have provided an AI layer on top of this BI tool wherein they can pass their query in a simple natural language format and get a quick summarized insights of the same along with detailed analysis. Now, this is AI over BI interface. Now, to prevent the tool dependency, we have directly embedded the Metabase dashboard into our system so that users can refer to the dashboard data directly over here, and whatever the queries they have regarding this dashboard data, they can simply go to the chat interface and put their queries over there. Suppose the user want to query regarding category and subcategory wise sales and profit performance based on dashboard data and KG driven business logic, it will provide a quick summarized insights along with detailed analysis of the same. As you can see, it has shown technology being the highest performer in sales and profit, while the office supplies with binders as the lower performer. If we look at detailed analysis, it has also provided the key evidences based on which it has answered this query along with statistical data. It shows technology being the sales of 69,960 and the sales of office supplies as 3,290. It has also provided the supporting visualizations from the dashboard for better understanding of these insights. It shows sales and profit category and subcategory wise performance. Now, one more key feature it has provided is recommendations based on these insights. As the technology has higher sales while the office supplies have lower sales, it has provided recommendations suggesting the leverage of strong performance of technology and increasing the investment in technology category. Since the sales performance of office supplies is low, it has recommended to address the critical underperformance of office supplies and look at the underlying causes. It has also provided the different decision areas like pricing strategy, executive decision making. It has also shown what we need to monitor next. Now, for technical purpose, we have also included detailed execution trace of entire workflow, including intent type that is being identified. In this case, the intent type is descriptive, then the different KPIs, the keywords that are being selected, the KG context, Metabase fetched, the visualization plan, recommendations, etc. One can also verify this entire detailed analysis by switching to the dashboard tab. Now suppose user wants to pass another query regarding the region-wise performance as well as segment-wise alignment in contribution. It has provided the quick summary saying that the corporate segment has higher contribution in sales and the region, in case of region, the south leads the sales. Along with that, it has provided the detailed analysis with the key evidences, the visualizations, including contribution percentage, regional performance, recommendations, decision areas, what we need to monitor next. If you look at the execution trees, it has shown that it is being identified as comparative intent type. This is because we are comparing across different segments and different regions. This concludes our demonstration.
Hi, I am Dheeraj Shreyan, a GenAI expert at 5x3, and today I will be going to explain you about the backend workflow of our project. It starts with the knowledge graph generation. We begin with the business stakeholder by asking them some questions and understanding their business need. All those business input are captured in a structured format and passed to the LLM-based knowledge graph generator. This component automatically builds the knowledge graph by creating nodes and relationships. Now for better understanding, let's look at the knowledge graph that we have generated in Neo4j. As explained earlier, this is the KG that we have generated, considering all business rules, guardrails and other dependencies. These are all the nodes present in our KG. For better understanding, let's consider the sales KPI now. These are all the nodes connected to sales KPI. The yellow nodes are the keywords mapped to the sales. This is the primary KPI profit, which depends on sales node. The sales growth and the average order value are derived from the sales KPI. These are the business rules and guardrails that are enforced on the sales KPI. These are the dimensions supported by the sales, and this is the business area that gets affected by the sales KPI. Now that we have understood the knowledge graph generation part, let's look on to the actual workflow of the system. As we saw in the demo, on the initial load, the whole BI dashboard is embedded onto the system. Parallelly, in the backend, Metabase data fetcher agent extract all the visualization card from the dashboard and store it in JSON format. Where user passes a query in the chat interface, it is first passed to the intent identifier and the keyword selector agent. Using LLM, it identifies the intent, whether the query is diagnostic, comparative or descriptive, and which all keywords are present in that query. Now, all the identified keywords are further passed to the KPI selector agent, which maps those keywords to the respective KPI using the knowledge graph. All those mapped KPI are passed to knowledge graph context builder agent. It extracts all the relationship from the knowledge graph for that particular KPI. As we saw earlier, for sales node, it will extract all the connected nodes and relationship. All those fetched context and initially extracted Metabase data is passed to the visual selector agent, which uses LLM to select the relevant visualization with respect to user query and the extracted context. The selected data is passed to the visualization planner and generator agent, as the name suggests, which selects and generates best chart for the selected data. In parallel, the fetched context and the selected data is passed to the insight and the recommendation generator, which both uses LLM to generate business relevant response to the user query. All those agent output are then displayed onto the front end. Overall, this solution provides an effective reasoning on top of traditional BI dashboard and thereby converts the dashboard from passive reporting tool to active decision support assistant. This system can be further enhanced by integrating external databases for answering queries that go beyond scope of dashboard data, automating the KG generation and providing intent-specific personalized responses. Additionally, by adopting Google A2UI concept, a UI-aware agent can replace the existing visualization logic. This would allow the system to dynamically generate data-aware and context-driven visualization, resulting in more adaptive and intelligent user interface.